Hey everybody, welcome to Beyond the Bench. We have a really exciting show for you all today. Alex Schwartz, Embedded Business Line Manager of SolidRun.
I was doing AI almost 20 years ago. It's not a new thing. What changed is the accessibility. It became very much accessible for everybody. If you're looking for something much more optimized in terms of hardware, then you would probably go and look deeper into the different ARM solutions.
Everybody's excited about robotics. I was on a call with NVIDIA this week and they're calling everything robotics, but at the end of the day, the most important piece is computer vision. How are you guys thinking about the changing landscape coming up?
It's
Hi everybody, welcome to Beyond the Bench, where we discuss taking hardware through production and the stories along the way. My name is Bill Brock, CEO of Peridio, the ecosystem for building and maintaining advanced embedded products.
Hey everybody, welcome to Beyond the Bench, Hardware Stories That Matter. We have a really exciting show for you all today. I have here joining us Alex Schwartz, Embedded Business Line Manager of SolidRun. And SolidRun is a true industry leader in the compact production-ready embedded solution space. They work very closely with NXP, NVIDIA, Marvell, and others. AMD, very important. And really excited to have you on the show today, hear what you guys are building, what you're seeing in the industry, and all the things. So thanks for coming on, Alex.
Thank you very much, Bill. It's a pleasure being here.
Well, before we get in too much into SolidRun, I'd like to hear a little bit about your personal background. How did you find yourself in this world?
Oh my God. Okay. So I've been a tech entrepreneur for nearly 25 years. Since my sort of teenage days, I was also always like into technology. And as an entrepreneur, I can say that we can always use a handful of luck. So I happen to be sort of in the right place at the right time and, use the opportunity as they came.
And so your entrepreneur, was it mostly in, were you like software background, hardware tinkerer, or were you just selling cars and just happened to start selling silicon? Like what's the arc here?
On the personal level, I have an electrical engineering background, and I just happened to found several startups, things like that, and things just rolled from one to the other until I merged one of my companies into SolidRun, and that's how I came to be here.
Very cool. What was that company?
Oh, that was ASD, and that company was focused on developing instruments for biological research.
Cool. Cool. Very cool. My background's in software and I spent a lot of time in academia and I was always really impressed with folks that moved from electrical engineering and computer engineering in particular into the software domain. And I was more used to like high level programming, like I don't know, like scripting languages down to C++. plus plus. And it was always really cool getting to work alongside electrical engineers who were explaining things to me like memory management and how these things worked under the hood and how they deeply understood the like performance tuning and optimization of the software at a level that I was just like, I got no idea, dude. Help me out.
The funny thing is that, from when I was a teenager, I was mostly into software. Okay, and back at the early days of DOS and the first x86 machines. Uh, um, so I was very interested in game programming, and to have a proper game back at the time, you have to be really thoughtful on your machine resources and write very much optimized code. And I was eager to explore how come and what are the actual hardware limitations are. And that's how I came to be a hardware engineer.
And that's more important than ever right now. So like nice little segue. SolidRun has a premium reputation for producing incredibly high quality songs, SBCs, end-to-end solutions. Before the call, we were talking about AI in the field. How are you guys thinking about performance and AI on device?
I'll start again on a personal perspective. You know, I was doing AI almost 20 years ago. Okay. So it's not a new thing. I guess that what changed is the accessibility. It became very much accessible for everybody, and especially since the introductions of the NPU, which allows on the edge inferencing, and of course the price. Okay, and add to that all the recent software developments that allows very easy entry into this world, and here we are. Okay, so I think that what we will see, and that's important for us in SolidRun to be able to enable it, because at the end, as a hardware company, we are enablers, right? So what I think will happen is that we will see more and more lower power, higher capability inferencing, computing available for basically any type of device.
And what is making this more accessible on the, like, let's talk about software side first. I mean, hardware, there's just always new chips, new performance, lower power, higher tops, etc. But like, what is making this more accessible on the software side?
Well, I think that the ability to really implement your models and deploy them to a hardware without any embedded or hardware knowledge, or I
Perfect.
wouldn't say any, but a very basic level. Okay,
Yeah.
because and we can see it more and more that you know guys that are coming from background of algorithms and AI don't have deep knowledge of hardware,
Right.
okay, and embedded software development. But the ecosystem, the tools that exist today allows them to have their models deployed to edge devices pretty easy, and that gets better and better, not from year to year, but I guess nowadays from month to month.
And how closely are you working with your end customers? Is SolidRun a type of place where you just go and buy solutions and they get started developing on something completely turnkey? Or are you working with the customer and helping support the actual integration to some extent?
Well, I would say that we are very flexible, so we support all the range. Okay, so you described sort of the edges, okay, but we support all the range in between as well. Okay, so we're very much a customer facing company.
Great, great. I saw a very nice uh, camera solution. And there's a couple companies doing just purpose built, like the whole company is an embedded camera for like hunting purposes. But what are you guys doing on like the like completely closed solutions in the computer vision space?
Okay, so you probably refer to our SolidSense AIoT platform, and that's something that actually was born. One of the first things that came to life after I joined SolidRun, and that's really the inspiration. By the way, it came from your everyday trail cameras. Okay, so there's this amazing story, a true story, by the way, that and you have your background from academia, and back in ASD I was working a lot with wildlife researchers. Okay, and there was this large group that deployed all kind of monitoring equipment in Central America's jungles to monitor some extinct species, and they collected this data over almost a year.
Okay.
Okay, and once they analyzed that data, they actually discovered a drug cartel operating in the region, and there's lots of cocaine trafficking going on there. So they reported to the to the government there, and that cartel was, I don't know, completely stopped, but at least some action was done to stop trafficking in that area. And when that specific scientific paper was published, that brought lots of awareness on governmental levels that, hey, we can support wildlife research and support those scientists that deploy all kind of monitoring hardware, and that can provide us with this benefit of monitoring on previously unmonitored locations. Okay, so there's lots of initiatives now in different countries in the world to do that. So when I was looking at SolidRun's growing portfolio of AI-enabled SOMs, I came up with this idea of, hey, let's have a platform that would be really inspired by this sort of wildlife monitoring, but would really allow different hardware platforms. So it basically can support any of our AI-enabled SOMs, okay, in a single platform. Okay, so a company that is looking to develop some sort of vision AI application can have this platform enabled to evaluate any of our SOMs. And once they pick up their best solution for their application, hey, this is a deployment-ready platform. Okay, so they don't need to go into any long-term R&D cycles. They can just take it as is, can help them to scale it down, optimize, cut out unneeded stuff, and here you go.
Very cool. And this device in particular that we're talking about, do you have a preferred chipset? Do folks commonly is it typically bundled with one vendor or the other, or is it flexible and you support multiple like SoCs or SOMs on the SOMs under the hood?
Exactly. So the whole idea is to be flexible. The whole idea is to have a single platform to support, NXP, Renesas, Halo, you name it, all of our SOMs that are, that have an NPU and capable of doing inferencing.
And so I know you're not going to pick favorites over your partners right now. I won't put you in that scenario. However, how do you start to navigate this for your customer and recommend an NVIDIA over AMD or vice versa or Renesas? Like, when is the different, like, how do you pick the silicon for the right use case?
Oh, you ask the hardest question, but it's really the question that I like the most. But and that's one of the goals that we set ourselves here in SolidRun, because what we can see is that people really don't have good metrics today to properly compare those solutions. Okay, so one of the things that we want to introduce on top of this single platform that would really allow to compare different vendors, different MPUs on a single platform, because that's important. We would also invest in some software tools as well, okay, to really allow people to have completely, I would say objective comparison of the different solutions, because it's really hard to compare those today.
Yeah, yeah. Let's go super high level then. Talk to me about ARM versus x86. When makes
Oh.
sense for what in the field?
um okay, so that's a really, really, really hard question, and I know that it's a debate, and there are lots of discussions going on around this. And as more as the x86 gets down on power consumption, okay, this discussion becomes more relevant. But I would say that in general, if you're looking for something much more optimized in terms of hardware, then you would probably go and look deeper into the different ARM solutions. Okay, but if you're looking for something that should really work out of the box in as many scenarios as can possibly be, then you would probably go with the x86, because you have bias and that's it, basically, right? So you will roll out your Ubuntu, or your Windows, or your Debian, or whatever it is, right? Whether going ARM Well, it's not that easy, though many claim it will, but you know, down the line, there are frictions.
Makes sense. And do people come to you with that idea already in mind? Are they already deciding on their software stack, or is that something that you consult with them in the process?
Oh, we have all of them. Like, yeah, yeah, absolutely. Like, we have customers that are coming, and just half an hour ago, I finished a conversation with a customer that, their solution is really, really like, it's almost a wearable. Okay. It's a very, very mobile device, and they're fixed at x86.
Hmm.
Okay. And they're just not ready to do anything else. Okay, but it's really customer dependent. There are those who are really open, and then we serve as their sort of trusted uh, um, consultants. Okay, but there are those that are just fixed on their solution, and we do our best to give them the best solution we can.
So we talked before the call, and I asked you what are the verticals you're excited to go into, and you said, I don't actually know what's going to happen in the future. We provide a good platform for all customers, but like, what are you seeing in practice? What have been some of the surprising use cases? What's really shocking you right now?
Oh, so there are several nice applications that we are discovering now, and some nice tractions that we are getting on, for example, the NXP Layerscape. Okay, it's a multi-core, very powerful ARM processor by NXP, intended for basically high-speed networking. That's what it's good at. Okay, and what we've discovered is that that specific line of processors can be qualified for uh, low Earth orbit for space applications. So we're getting a lot of traction now on low Earth orbit satellites. Okay. Um,
Did you think that you would be a space company?
no, we won't be a space company, but we're definitely going to help space companies that are building satellite, to have their computing platforms designed. That's definitely something that we are into.
Very cool. And what is so the customers you're talking about right now? What are some of their? Are they just doing the satellites, or I've heard some rumors of people even building data centers for space because the cooling costs are lower.
Yeah, yeah, yeah. um, so yeah, we are being approached by all types of companies, okay, including some that are, thinking of doing something on the moon.
What are they doing on the moon? What?
Uh, I'm not sure that I can go into this, and of course that I don't know everything, but I would say that the most traction today is lowers satellites, because that became very cheap and easy to deploy. After Starlink's success, there are lots of interest in that.
Very cool. Um, so talk to me a little bit about are you guys do you play it all on like the IPC market, or are you typically doing the full closed solutions?
We see ourselves as um, embedded computing specialists. So we supply basically what we call building blocks, starting from the very low end, which are usually SOMs, up to fully enclosed IPCs and anything in between. Okay, so we are, as I sort of told you before, we are customer facing company, so we can do anything. Okay, and I think that what's so special about us is that our evaluation tools, our EVKs, if you will, are deployment ready platforms. So if somebody is looking to evaluate one of our let's say AMD based SOMs, okay, we say, hey, you go and buy our IPC, because that's
Hmm.
what you have inside. You have our SOM inside.
They're using the the IPC essentially as an EVK, and then they're able to just switch to a camera or switch. Yeah, very cool.
Yeah. So any of our evaluation platforms are deployment ready, or those are as close as you can get to a real deployable products.
Nice.
So when
And
you
so,
do, when
yeah,
you
go
have
ahead.
a reference to roll out your own design, it's not some sort of, uh, uh, you know, um, something that is really just a general reference. It's an actual reference of something that is there and working.
And so, say somebody starts with, I'm going to go in on Renesas, and you give them the IPC or whatever the base target is. Do they typically stay within that same family through the full production, or do people ever switch from Renesas to AMD, for instance? Like, what does that look like, and as far as like a product life cycle?
No, I don't think that I can recall anyone switching from, low-end Renesas to an x86, but I would say, well, first of uh, uh, all our lower end SOMs are same form factor. Okay, and in terms of same family lines, those are actually also fully compatible. So what we do have a lot is customers that are starting with a certain SOM from the, let's say, Renesas family. Let's say, I know, G2L, and then when they finish their design, they see that, hey, the G2L is too much for us. We can go and optimize our cost, and we can do a G2LC or G2UL, and they just switch SOMs. They don't need to redesign anything.
Very
Okay,
nice.
so we allow that range of possibilities, and because they're the same form factor, we have customers that have been evaluating, different families as well. Like we have customers evaluating on the same carrier INX 8 and Plus and Renesas G2L or whatever.
Who is winning in the ARM space right now? Who are you most excited about? I mean, you mentioned NXP and Renesas. Like, what are you seeing coming up next that you think is going to be really high impact?
Oh, well, I think that it's really exciting to see how Renesas evolved, because when they started the engagement with them, they were like in their very first stages, and uh, um, you know, lots of things were not ready yet. And nowadays, if you look at the existing things, but also on their roadmap, and it's starting to look very very exciting, and the level of the of their AI SDKs and overall support is really really amazing. I think that they're doing an amazing progress there. So I'm looking forward seeing what will come up next. I have a certain idea of the few next things that will come up, and we are looking forward.
Awesome. Everybody's excited about robotics. I was on a call with NVIDIA this week, and they're calling everything robotics. But at the end of the day, the most important piece is computer vision, right? Because that's the perception, and then that feeds into control. You throw some AI on it. How are you guys thinking about the changing landscape coming up?
It's a really difficult question because we are new to NVIDIA platforms, let's say. Okay. um and we're looking at the higher end platforms, and of course at the Thor that just came out.
I'm trying to
And
get
I
one right now.
Yeah. And you look at this, and for somebody who is really into tech, that's really exciting. And you say, hey, wow, that's amazing, the amount of stuff that we can do with this, and all the uh, um, humanoid robotics market that is really catching the hype now. Okay, but in terms of real market traction, it's hard to say, because we don't see humanoid robots wandering around the street yet. Okay, so this is how usually innovation goes. It has to start somewhere, right? And we at SolidRun, we want to be able, again, to enable access to all of those technologies to our customers, to be able to do something amazing with those. Okay, uh, um, so we are watching closely on all the evolvements from all the vendors, and we pick up things that we think uh, uh, will get good tractions in the following years, exactly as we did with this layerscape. When we started to work on that, nobody was thinking of low Earth orbit applications. We just look at it and we'd say, well, wow, that looks great. We think that there are some nice things that people could do with this. Okay. And only after several years we are starting to get more and more and more traction. So that's how things evolve. We have to let the time pass, but we must enable all of those to our customers.
So the NVIDIA, and you mentioned that you guys are a little newer to NVIDIA. Is this the NVIDIA integration customer driven? People are just buying NVIDIA because it's the name, or are you seeing real justification for the high end near GPU on device?
Ah, So at the moment, we chose to enable and to go into the higher end platforms. Okay. Uh, um, because at the lower end platforms, we still see lots of confusion. Okay. So people are getting those, though they're not certain exactly what the application would be, and many getting those, though their main application is very low power inferencing, and that's not something that you need an NVIDIA for.
Right.
So there's lots of confusion still getting there at the lower end platforms. Okay, so we decided, because we have this very wide portfolio of SOMs with NPUs. Okay, so we don't think that we need NVIDIA for the lower end.
Right.
Okay,
No.
but
Yeah.
we do need it for those platforms that need a real-time sort of training capabilities, like you would do with humanoid robots and
Yeah.
stuff like that. Okay, or maybe some UAVs, for military intelligence, stuff like that. So in those platforms, that's where higher end NVIDIA platforms can really excel.
Yeah, and we're experimenting a lot with these new models right now, and the video language models, the VLA, that's like crazy cutting edge. But the video language models are very impressive, and the idea of embedding that into a security camera could really cut down your software development cost. At a cost of inference, of course, but there's some really nice things that you can do with those, and the models are becoming very, very performant. And if you find somebody that can help you fine tune it, you can get something pretty lightweight. You can get like 10 frames per second, or 10 inferences per second on a video stream, which is freaking wild. It's very impressive.
Yeah, absolutely, absolutely. So again, it's really a matter of the actual processing that you need. And again, I'll just shoot you another funny story, a real story. Okay, I was visiting a company, and they done a really impressive MVP of a vision inferencing. Um, I don't want to go into specific names, but they chose a certain architecture of general purpose NPU, and one of the available on the market NPU accelerators. Okay, and that's how they did their MVP. And then they asked for our advice on how they could optimize that for something much, much, much smaller, cost effective, and power efficient. Okay, so one of the first questions that I asked them was like, okay, guys, so how much of that processing power that you have today you actually utilize, both CPU and NPU? And they went, well, we have no idea. Okay, and that's more, and that's something that we hear more and more. People just take some off the shelf stuff, do something, it works, but they have no idea what how they can actually optimize it. So I asked them to do their homework and find out. So they came back um, with an answer that they almost utilize, like, let's say, under 10% of the CPU, and 0.1 tops out of that accelerator that was more than 10 tops on the overall. So, and they had an amazing product, really, really, really amazing product. So what I'm trying to say here is that to run an amazing model today, you don't need that much of processing power.
That's really cool. Well, Alex, I think we're over time. I was going to keep it going. This has been a lot of fun. You satisfied about 60% of my intellectual curiosities here, so we made good progress. Um, yeah, but we covered a lot of ground. Thank you so much for coming on the show. If anybody is looking for some consultation or how to navigate this crazy landscape that we're all battling with right now, Alex is the man and SolidRun is the company. Thanks again for coming on, and we'll see you again soon.
Thank you very much, Bill. It was a pleasure, and I hope that we will complete the remaining 40% one time.
Oh yeah, we'll do it again. Yeah, I'm right on. All right, talk soon. Thanks, man.
Cheers.
All right, everybody. Just a quick reminder, this podcast is presented by Peridio, the ecosystem for building and maintaining advanced embedded products.